Today we are going to learn about arithmetic sequences. A sequence is a set of numbers that follows a specific pattern for getting from one term to the next. We will discover what makes an arithmetic sequence, how to find the rule of the sequence, and how to find an unknown term of a sequence in this lesson. First of all, arithmetic sequences are sequences that add the same value given to the next term, or to get to the next term. This is called the common difference and is noted with the variable d. Here are some examples of arithmetic sequences. In this first example, we can see that the common difference is 3 because to get to the next term for each of these, we are adding 3. When we add 3, we get to the next term. That 3 is the common difference. In our second example, we are adding a negative 8. You can also think of this as subtracting 8. So if we add a negative 8, 9 plus a negative 8, we get 1. 1 plus a negative 8, we get negative 7. And then 7, or negative 7 plus a negative 8, that's how we get to negative 15. So for this one, our common difference was negative 8. We were adding a negative 8. Our first one, our common difference was 3 because we added 3 each time. And our last one, we have the sequence 6.2, 6.6, 7, and 7.4. To get from each term to the next, we are adding a value of 4/10, so 0.04 each time. 6.6 to get to 7, if we add 0.4 or 4/10, we get 7. 7 plus 0.4, we get our last term of 7.4. So the common difference in this last sequence is 4/10, or decimal 0.4. So once we have identified the common difference, we can use that common difference to find the upcoming numbers in our sequence. So if we look at this example, in our sequence we have negative 9, negative 2, 5, and we have 3 dots. These 3 dots indicate that this is an infinite sequence, meaning it goes on and on forever. So from the terms listed, we can determine what the common difference is by identifying the pattern with those terms. And since this is an arithmetic sequence, I know that we are going to be adding the same value to get to the next term. So looking at each of these 3 terms, we have negative 9, negative 2, and 5. So one way to find the common difference, you can subtract the 2 values. Negative 9 minus a negative 2 is 7, or negative 2 minus 5. We end up adding 7 each time to get to the next term. So our common difference in this example is 7. So now to identify the next 4 terms, we start with our last term of 5, and we can add 5 plus 7 to get 12. 12 plus 7 gets us our next term of 19. 19 plus 7 gets us to 26. And 26 plus 7 gets us to our 4th term we want to identify of 33. So once you have identified that common difference, you can use that to find the next terms in the sequence. If we look at another example, in this example we have negative 4, negative 10, negative 16. I can see from this sequence that each term is smaller than the one before it. So I know that we are going to be adding a negative number. So to go from negative 4 to a negative 10, we are adding a negative 6. And to go from negative 10 to negative 16, we are also adding a negative 6. So in order to get to each term, we're adding a negative number. And in this case, our common difference is negative 6. We can say D equals a negative 6. So to get to the next 4 terms, again, start with your last one that you know, negative 16. So negative 16 plus 4, or sorry, that's let me take that off. Made a mistake here. Negative 16 plus a negative 6, you end up with a negative 22. So our next term is negative 22. And then negative 22 plus a negative 6, you get negative 28. And then negative 28 plus a negative 6, we end up with a negative 34. And for our last term that we wanted to identify, negative 34 plus a negative 6, we end up with negative 40. So those are the next 4 terms in that sequence. So we can also figure out any given number in a sequence by looking at the sequence itself. To do that, we need to identify the different parts of the sequence and use a simple equation to find the unknown term. So first we want to identify the different values. Each sequence and each term in a sequence is given a specific value. The first term in a sequence is a sub 1. A sub 1 represents our first term. So in a sequence, if we use one of our sequences from before, we had negative 4, negative 10, negative 16, negative 22, and so on. Our first term is a sub 1. Our second term would be a sub 2. Our third term would be a sub 3. And our fourth term would be a sub 4, and so on. So it's important to remember that the first term is noted by this a sub 1. And then each term after that, the 2, the 3, the 4, and so on, represents the position of that term. A sub n means we're looking at the nth term, so an unknown term value. And then n, going along with this one, n is that term number. So for example, if we want to find the 8th term in a sequence, n would equal 8. So we'd be looking for a sub 8 to find that 8th term. And d we already know. D we know is the common difference. So when looking at a sequence, if we can identify these parts, we can come up with what's called an explicit rule of a sequence and figure out what that unknown value would be. So looking at the variables and the terms that we just talked about, this is the formula or the equation that we can use to find any unknown value in a sequence. In this formula, we have our unknown value, so a sub n. We have our first term, a sub 1. D is our common difference. And this n minus 1, so the term number we're looking for, minus 1. So let's look at how we can use this equation to find the explicit rule of an arithmetic sequence. So let's look at how we can use the explicit rule for a sequence. So we can think of the explicit rule for a sequence. It's like finding the function equation that we would use to find any value in that sequence. So in this example, we're given the sequence 1, 4, 7, 10, and 13. To start off, we need to identify the first term, so a sub 1, and figure out what the common difference is, or d. So looking at this sequence, I can see that my first term in this sequence is 1. So a sub 1 is 1. Now looking at our sequence, we can figure out the common difference. So 1 to 4, that would be adding 3. And we always want to just double check to make sure that we found the right one. 4 to 7, also adding 3, 7 to 10. So each of these are adding 3. So in this case, d equals 3. Now that we know those two values, we can put them back into our equation. So we know that a sub 1 is 1 and d is 3, and then simplify to find our explicit rule. So in this case, if we put in 1 for a sub 1 and 3 for our common difference, we are left with 1 plus 3 times n minus 1. Now to simplify, we want to use our distributive property, so multiply 3 times n, and then 3 times the minus 1, to get 1 plus 3 times n is 3n, 3 times the minus 1 is a minus 3, and then finally simplifying 1 minus 3, we get a minus 2. So our explicit rule that we have here, a sub n equals 3n minus 2. And how I got that minus 2? 1 minus 3 is a negative 2. And again, like I mentioned before, we can think of this as a function equation. This is the same as if we had it as the function f of n equals 3n minus 2. So now let's look at, now that we've found this explicit rule, let's look and see how we can use this explicit rule to find an unknown value in our sequence. So using that same sequence, and we've got it worked out again for how to get to that explicit rule, let's figure out what the 8th term in this sequence would be. And some of you may be thinking, well, couldn't I just add 3, 8, to get to the 8th term? And you could, but that's not really practical, because if you wanted to find the 100th term, it would take you a long time to add 3 out to the 100th term. So it's easier to identify what the explicit rule is and then use it where we substitute 8 in for n, and we'll be able to find that 8th term. So taking our explicit rule, we have a sub n equals 3n minus 2. And if I want to find the 8th term, I'm going to replace n with 8. So a sub 8 equals 3 times 8 minus 2. Our 8th term is 24 minus 2, giving us our 8th term of 22. So the 8th term in this sequence is 22. Now if we wanted to find the 100th term, you just replace n with 100. So let's say I wanted to find a sub 100. I would have 3 times 100 minus 2, giving us 300 minus 2, and giving us our 100th term of being 298. So that is much faster than adding that common difference that many number of times. Once you've identified your explicit rule, then you can use it to find the next term or an unknown term. So let's look at one more example. If we want to find the explicit rule for this sequence, again, first identify a sub 1 and identify the common difference. A sub 1 is our first term. Our first term is a negative 7. So negative 7. And our common difference, negative 7 to negative 2. And then negative 2 to 3, 3 to 8. Looks like we're adding 5. So our common difference is 5. So plugging into our equation, our first term is a negative 7. Our common difference was 5. And then we just simplify to find our explicit rule. So a sub n equals negative 7 plus 5n minus 5 to give us our explicit rule of a sub n equals 5n minus 12, because negative 12 minus 5, or sorry, negative 7 minus 5 gets us to a negative 12. Then once you have that explicit rule, you can use it to find any term in a sequence. In this example, same sequence, we want the 15th term, so you replace n with 15. So a sub n equals 5 times 15 minus 12. 5 times 15, that's 75, minus 12 to get our 15th term of 63. So a sub 15 equals 63. And then real quick, just to review, today we learned that an arithmetic sequence uses a common difference, noted D, which is the same value added to each term to get to the next term. We also learned how to develop the explicit rule for a sequence by using the equation a sub n equals a sub 1 plus d times n minus 1, where a sub n is the unknown term, a sub 1 is the first term, and d is the common difference, and n is the term we're trying to find. And finally, we learned how to use the explicit rule of the sequence to find an unknown term by replacing